Hello students. So the question is saying that figure shows a man of mass 60 kg standing on a light weighing machine kept in a box of mass 30 kg. The box is hanging from a pulley fixed to the ceiling through a light rope, the other end of which is held by the man himself. If he manages to keep the box at rest, what is the weight shown by the machine? And second question is asking what force should he exert on the rope to get his correct weight on the machine? So this is a box in which a person is standing on a weighing machine, very light weighing machine. We have to take mass of the weighing machine almost zero, and the person is standing on the weighing machine, and the box is connected to a rope which is going over a pulley, light pulley, and then other end of the rope is held by the man itself. Now the man is holding the rope, and the question is first part of question is saying what is the weight shown by the machine. So first question arises that what is weight shown by the machine? Suppose that we are standing on a weighing machine. What it will measure? So actually weighing machine will measure the normal reaction applied by us on the machine. Like suppose that when you stand on a weighing machine, you exert some normal force on the weighing machine. That normal force is measured by the machine. If you will hold some rope and then stand on the weighing machine, then machine will not gives you correct weight, because now some of your mass or some of your weight will be tolerated by or managed by the rope, tension in the rope. Or if you are holding some other object, then that normal will increase and machine will give you wrong weight. So if you want to measure your correct weight, you have to stand on the weighing machine alone, and weighing machine should also be at rest. If weighing machine is going upward or downward, we all know normal changes. If weighing machine is going upward with some acceleration, normal will increase. If going downward with acceleration, normal will decrease. So what weighing machine will measure? Weighing machine will measure the normal reaction by the foot of the person on that machine. So actually when the question say what is the weight shown by the machine, it means the question is asking normal force between the person foot and the machine. Now to solve the first part of question, we'll make free body diagram of the person and the whole system. So first we'll make free body diagram of the person. So this is the person, suppose that, nice drawing. Now downward force will be mg, mass of the person is 60 kg, so 60 g, and since he is holding rope, when he will pull the rope downward, there will be a tension generated in the rope, and that tension will apply on that man in upward direction, so call it T. Any other force acting on it? Yes, one more force will be acting on it, the normal reaction by machine on the foot of the person. So there are three forces acting on the person: tension, normal, and gravitational force, or we can say weight of the person. Now if we make free body diagram of the box, this is our box, that person, machine, everything is in this box, and you can clearly say two rope is connected to the system of rope plus man. If you only take box, then only one rope is connected, but when we take man plus box system, then one end of the rope is held by man and one end is connected to the box. So 2T force will act on this in upward direction, T plus T, and downward total weight of this system is 60 plus 30, 60 kg man, 30 kg box, so it will be 90 g. Now the first question is saying what is the weight shown by the machine. So now we'll write equation of force for both the free body diagram. It is in equilibrium at this stage, so total force acting in both case will be 0. So here we can write T upward plus normal also upward is equal to 60 g. And for second free body diagram, we will write 2T is equal to 90 g. So T is equal to 45 g. When we'll put the value of T here, we'll get N is equal to 15 g. If we take the value of g to be 10, then it will become 150 Newton. So weight shown by the machine in this condition will be 150 Newton force or 15 g Newton force. So this is the answer for first question, 15 g. And in this case, the whole system is in equilibrium. The man, the box, everything is neither going up nor going down. But now in this condition, weight shown by the machine is not correct. Machine is showing his weight as 15 g, but actually his weight is 60 g. So the weight shown by the machine is wrong. Now the second question says that what force should he exert on the rope to get his correct weight on the machine. Now he have to increase his force such that, or decrease his force, anything can be possible, such that the machine start to show his real weight. So let's solve. Again we will make simple free body diagram. Here to downward 60g, upward normal, and upward tension. This tension will be different because last time he was applying 50 Newton force. This time, sorry, last time he was applying 45 Newton. So tension was 45 Newton. This time we don't know how much force he have to apply. The question is asking how much force he have to apply on the rope. So we have to find this tension actually, and this tension will be different from this tension T1. This tension will be different from this tension T, which is 45G. So here we will denote it by T1, not T. Now again we will make free body diagram of the box. Downward force will be 90g total mass, and upward force will be 2t. Same thing again. But in this condition, when the person have increased upward force, now the whole system started to go upward. In this case, the whole system will go upward with some acceleration. So assume, and both are connected. Person is standing in on the box, inside box. So both will go upside with same acceleration. So assume that both are going up with acceleration a. Now we'll write force body diagram. So for the person, we'll write T1 plus N minus 60g, because 60g is downward, is equal to 60a. And when we'll put the value of normal, because he's saying machine should show exact weight. So his weight is 60g. So n should be 60g, so that machine will also show the 60g, because machine will show this normal. So when we'll put the value T1 plus 60g minus 60g is equal to 60a. So from here simply we can say T1 is equal to 60a. Now when we'll write equation for this one, it will become 2t is equal to 90g. Sorry, this will also go upside with acceleration, not 90g. 2t upward and minus 90g is equal to 90a. This is the second equation. So from first free body diagram we got T1 is equal to 60a, and second we get 2T1. This is also T1, not this time also tension will be T1. 2T1 minus 90g is equal to 90a. So let's solve these two equations. First equation is T1 is equal to 60a, and second equation is 2T1 minus 90g is equal to 90a. 2T1 minus 90g is equal to 90a. Now just put the value of T1 here, so it will become 120a minus 90g is equal to 90a. So 30a is equal to 90g. So a is equal to 3g. Now when we will put the value of a in this equation, or here we have already this equation, because we have to calculate the value of T1. T1 is the tension developed in the rope, and man will also apply same force. How much force man is applying on the rope, same force will be developed by the tension, as tension. So we'll write T1 is equal to 60a. So 60 into 3g is equal to 180g. So T1 is equal to 180. If we take g is equal to 10, so 1800 Newton. If g value is taken as 10, then the force the man need to apply on the rope is 1800 Newton. Means here the man have to pull down the rope with a force of 1800 Newton. I hope you understand this question. Thank you for watching. Keep learning.